Hello and welcome to this episode of my tutorial video series. In this video, I will solve two problems on demand function of theory of demand under microeconomics. As you know, practical problems on economics, both micro and macro, are solved mostly by using calculus, and here I shall do that only. And I am going to provide you with a number of solved advanced problems on a number of topics of micro and macroeconomics, namely theory of demand, cost function, production function, consumption function, then market equilibrium, and so on and so forth. So please look at the whiteboard, the way I am solving these two problems, and if you can understand the solution, then I can assure you that you will have a reasonable level of command on demand function. I mean to say, in solving practical problems on demand function. So please look at the whiteboard with reasonable attention. Now we have two problems to solve. This is problem number 1, this is 2. In problem number 1, a demand function is given. What is the demand function? P equals to A minus BQ whole square, where A and B are greater than 0. Now in part 1, we have to show the curve is downward sloping. That is, the demand curve is downward sloping. And in part 2, we have to show that the curve is convex to the origin. So I am solving the problems on the right side of the whiteboard. Solution 1. What is that? The curve is downward sloping. The curve is downward sloping. We have to prove this from this demand function. The demand function is P equals to A minus BQ whole square. Now remember, this is actually inverse demand function because the original demand function is of this form: Q equals to A minus BP, or Q equals to A into B, P B to the power minus 1. This is linear and this is curvilinear. This is linear and this is curvilinear. Okay, that means this is straight line and this is non-straight line. Now we have given this demand function, that is inverse demand function. This inverse demand function is required when we solve problems on average revenue, marginal revenue, etc., because total revenue TR equals to P into Q, that is price per unit, into number of units sold. In that case, this inverse demand function is used. From here we can find out AR by dividing TR by number of units. We can calculate MR by differentiating TR, and so on and so forth. So inverse demand function is used in solving these problems. But here we will use this equation, this inverse demand equation, to show that the curve is downward sloping. Now what is the slope of the demand curve? Slope is given by dP dQ. So we have to differentiate P with respect to Q. Now differentiating, this is first order derivative, differentiating P with respect to Q. we get dp dq equals to d dq a minus bq whole square. This is equal to 2a minus bq into minus b. If you differentiate bq minus bq, we get minus b. So this is equal to minus 2b into a minus bq. Now since a and b are greater than 0, minus 2b into a minus bq must be less than 0, isn't it? If a and b are positive, then the value of this expression is negative. Minus is already given here, negative sign is already given here. So minus 2b into a minus bq is less than 0. This means, therefore, the curve is downward sloping. So part 1 of problem number 1 is solved. This is part 1. Now here I am solving part 2. That is, we have to show that the curve is convex to the origin. A curve to be convex to the origin, d2p dq square must be more than 0, must be greater than 0. That is, for convexity, d2p dq square must be greater than 0. That is second order derivative of the inverse demand function. Now we have already found out the first order derivative, that is minus 2b into a minus bq. So if we differentiate this, then we shall get d2p dq square. That means if we differentiate this, then we shall get second order derivative of the inverse demand function. Correct? So dp dq is equal to minus 2b into a minus bq. Therefore, d2p dq square equals to minus 2b equals to d dq of minus 2ab, correct, plus d dq of 2b square cube this is equal to, this becomes 0 because a and b are constant, so this is 0. So 0 plus, if we differentiate 2b square cube, we get 2b square into 1 equals to 2b square. Now b being more than 0, 2b square is greater than 0. This is greater than 0. And for convexity, we need d2p dq square to be greater than 0. And we have proved that d2p dq square is greater than 0. Hence, the curve is convex. The curve is convex to the origin. Okay. So problem number 1 is fully solved. Our demand function is given p equals to a minus bq square. That is actually inverse demand function where a and b are greater than 0. The problem has two parts. In first part, we have to show that the curve is downward sloping, and in the second part, we have to show that the curve is convex to the origin. So in the first part, we have differentiated the inverse demand function. That is, we have found out dp dq, and dp dq is the slope of the demand curve, and the value of dp dq is minus 2b into a minus bq, and a and b being greater than 0, the value of this minus 2b into a minus b is less than 0. So the curve is downward sloping. And in the second part, we have to show the curve is convex to the origin. For convexity, d2p dq square must be greater than 0. This means we have to take second order derivative of the inverse demand function p equals to a minus bq whole square. Now we have already found out the first order derivative, that is dp dq, which is equal to minus 2b into a minus bq. Now if we differentiate this, then we shall get the second order derivative of the original inverse demand function. So dp dq is minus 2b into a minus bq. Therefore d2p dq square equals to d dq minus 2ab, d dq of minus 2ab plus d dq of bq into 2b, that is 2b square q. So this becomes 0, d dq of minus 2b is 0 because a and b are constant, and 2b square q becomes 2b square into 1. Now b being greater than 0, 2b square is greater than 0, hence the curve is convex to the origin. Correct? Now come to second problem. What is the second problem? It is given in a two commodity economy. In an economy where there are two commodities, that is, the consumer is consuming only two commodities. Number one, show both the commodities can be normal. Number two, one commodity can be normal and the other can be inferior. And number three, both the commodities cannot be inferior. That is very important. Both the commodities cannot be inferior. The commodities can be either both are normal, or one is normal and the other is inferior, and both the commodities can never be inferior. Okay, so we are solving problem number 2. Solution 2. The budget line, budget function m equals to xpx plus ypy. That is, x and y are the two commodities. Px is price of x and py is price of y, and m is money income of the consumer. Px equals to price of x, py equals to price of y, m equals to money income, and x and y are two commodities. Okay, so we have constructed this budget function, that is m equals to xpx plus ypy. The consumer is exhausting the full money income into these two commodities only. Now, DM equals to Px dx plus Py dy. Correct? Therefore, dm by dm equals to Px dx by dm plus Py dy by dm equals to Px dx dm plus Py dy dm correct? Now this is equal to 1, dm by dm is equal to 1. So Px dx dm plus Py dy dm equals to 1. Now come to number 1. If dx dm and dy dm greater than 0, this relationship holds. The relation holds. Right? That means if dx dm and dy dm both are greater than 0, this means both the goods are normal. This means both are normal. Let me draw a demarcating line. If dx dm and dy dm greater than 0, then both the commodities are normal, and if both are greater than 0, then this relationship holds good. So both the commodities can be normal. So part 1 is proved. What is part 2? One commodity can be normal and the other can be inferior. Suppose if x is normal, y is inferior, then dx dm greater than 0, dy dm less than 0. If this happens, then still this relationship holds good. If x is normal, then dx dm is greater than 0. If y is inferior, then dy dm is less than 0. If x is normal and y is inferior, that is dx dm is greater than 0 and dy dm is less than 0, then still this relationship holds good. That is px dx dm plus py dy dm equals to 1. Therefore, this means 1 can be normal and other can be inferior, right? If dx dm is greater than 0 and dy dm is less than 0, that is x is normal and y is inferior, then still this relationship holds good, that is px dx dm plus py dy dm is equal to 1. So one good can be normal and the other good can be inferior. Now come to number 3. Suppose both the commodities are inferior. If both are inferior, then dx dm less than 0, dy dm less than 0. If both the goods are inferior, then dx dm is less than 0 as well as dy dm is less than 0. Now if this happens, then this relationship will not hold good, because two negative quantities cannot make up one positive quantity. If dx dm and dy dm both are less than 0, then this relationship cannot hold good. Therefore, it proves both can't be inferior. Both the goods cannot be inferior. Correct? So all the parts are solved. Once again, I am explaining the solution to problem number 2. It is given that in a two commodity economy, show that both the commodities can be normal. It is a possibility. What is the other possibility? One commodity can be normal and the other commodity can be inferior. And number 3, the other possibility, both the commodities cannot be inferior. That means this is not possible. Both the commodities are inferior. Not possible. It is impossible that both the commodities are inferior in a two commodity economy. This is the budget function m equals to xpx plus ypy, where px is price of x, py is price of y, m is money income, and the consumer is consuming two commodities x and y in a two commodity economy. So dm equals to px dx plus py dy. We have differentiated m. Now we have divided both sides by dm. So dm by dm equals to px dx by dm plus py dy by dm. That is px dx dm plus py into dy dm. That is equal to 1, because dm by dm equals to 1. Now come to number 1. Show that both the commodities can be normal. It is a possibility. If both the commodities are normal, then dx dm and dy dm will be greater than 0. And if dx dm and dy dm both are greater than 0, then this relationship holds good. So this is a possibility that both the goods are normal. Come to number 2. One commodity can be normal and the other can be inferior. Suppose x is normal, y is inferior. Then dx dm greater than 0 and dy dm is less than 0. That means if dx dm is greater than 0 and dy dm is less than 0, then still this relationship holds good. That means this is possible that x is normal and y is inferior. In the same way, we can show that y can be normal and x can be inferior. That is, in that case, dy dm will be greater than 0 and dx dm will be less than 0. If y is normal and x is inferior, then dy dm will be greater than 0 and dx dm will be less than 0. In that case, still this relationship will hold good. So x can be normal, y can be inferior, or y can be normal, x can be inferior. So this is also a possibility. But this is not possible. That is, in third part, we have to show that it is not possible that both the commodities are inferior in a two commodity economy. Right? Here we have done this third part. If both are inferior, in that case dx dm will be less than 0 as well as dy dm will be less than 0. Okay, if x and y both are inferior goods, then dx dm and dy dm both will be less than 0. And if both are less than 0, that is, both are negative, then this relationship cannot hold good, because sum of two negative things cannot make a positive thing. Isn't it? If dx dm is less than 0 and dy dm is less than 0, px and py are certainly greater than 0. In that case, this cannot happen. This relationship, this equation cannot hold good. So both the commodities cannot be inferior in a two commodity world. Correct? Once again, please look at the whiteboard. Watch carefully. If you have any doubt in your mind, if you have any query, if you think more explanation is needed, please let me know through the comment section. I shall be more than glad to respond to all the relevant comments and queries. We have solved here two problems on demand function of theory of demand, and these two problems are very representative. If you can understand the solutions, you will certainly have a good command over the practical problems of demand function. Okay. Yeah, so far so good. I hope this is enough for this video, and you have enjoyed this video. That means this episode has benefited you. So long as understanding of practical problems of demand function is concerned, should you think the video is meaningful and useful, please do share the videos with your friends so that they are also benefited by watching this video. And please do subscribe and like our channel. Okay, and thank you very much for watching this video. Stay well and goodbye.